Hello and welcome to Dark Mode Code. Today I want to share a project with you. Here is an interactive map showing markers with number counters at specific latitude and longitude. This is dynamically driven by a CSV file. The map is persisted by exporting it as an HTML file. Everything used to create this map is entirely free. The map data is freely available through the OpenStreetMap Foundation. Required attribution to OpenStreetMap is automatically generated in the bottom corner of the map. This project is written in Python and uses Jupyter Notebook to express building the map piece by piece. The timestamps for each section of the video are described here for easier navigation. All of the code is available at my GitHub repo, which is linked in the description below. There are both files for the Jupyter Notebook that I will be using and for the final code by itself. If you are not interested in running the notebook yourself, feel free to skip ahead to watch me go through it or see the final code. You can install the required tools and packages described here in the README, or use Docker and Docker Compose for an easy, throwaway environment. I will be going into some detail on running the Jupyter Notebook with Docker. Refer to the README for instructions on running with Jupyter Notebook locally or running the finished script by itself. For this demonstration, I will be using Docker to get my working Jupyter Notebook environment. Here is the Docker Compose file. We will step through it to clarify what it is doing. The image defines the Docker image we are using. Instead of building our own, we are using an official Jupyter Notebook image and changing a few things for our purposes. The container name defines what Docker will call the running container, just in case we need to refer to it or debug it. The ports bind the local machine port 8888 to the container's matching port where Jupyter Notebook is exposed. This will let us reach the website that the container generates. The command overrides the Docker container's normal command with this one. We are specifying that we want the notebook interface and to override the identity token. The identity token is a security feature that we are bypassing for ease of use. The first volume binding passes all the local files through into the container so we can access them and persist changes and output. And finally, the second volume binding puts an override file in place which just changes the color scheme to start in dark mode. We can start our container with Docker Compose up-d. Using Docker PS, we can confirm when the container is healthy and ready to be used. If the watch command is available in your environment, you can use watch instead of running the Docker PS command repeatedly with watch-n1 Docker PS. Once the container is healthy, you can open your browser to localhost 8888. Welcome to Jupyter Notebook. From here, we need to navigate through the work directory and choose our notebook. Just double-click on the work folder and then double-click on the map notebook file. There are a couple of quick notes I would like to mention before getting into the details. Browser extensions that alter your browser theme, such as dark mode extensions, can also affect the maps, so keep that in mind if you encounter color issues with this code. To be able to render the maps, we do need to mark this notebook as trusted. Just go to the File menu and choose Trust Notebook, then confirm with the dialog that pops up. This notebook contains notes and links to other sites and documentation. I will not be explicitly covering them all in discussion, but they may be of help if you get the files and want to experiment. Now that all that is covered, we can finally begin digging into the details. Here are the requirements that are driving the decisions made for this project. We need to display a map with markers. The markers are placed based on latitude and longitude data contained in a CSV file. Each latitude and longitude pair may appear more than once, which is indicated on the map marker. These pairs appear less than 100 times, so we only need to make sure single and double-digit counts look good. To make our map, we are going to use Folium. Folium is a Python library that leverages Leaflet.js to render maps in Python. Leaflet gets its map data from OpenStreetMap. OpenStreetMap data is freely available provided you credit them properly. The maps are generated with this credit in the bottom corner. Check their copyright and license page for further details. To install Folium, just run this pip command to install everything in our requirements file. The only thing in the requirements file is a specific version of Folium. Running this cell will cause pip to install Folium for us. Now on to discussing actually making the map. Folium generates a map with the aptly named map function. There are a number of parameters available to define the map as discussed in the user guide, but we are only concerned with a handful of them. The location parameter sets the center of the map using a latitude and longitude pair. The zoom start parameter sets the initial zoom level with higher numbers zooming further in, and the files parameter sets the tile set the map uses. The tile set just defines how the map looks. There are tileset options described in the user guide and more available at Leaflet's site as linked here. Let me execute this cell and show you some of the tilesets. This map uses the OpenStreetMap tiles, which is useful for a lot of common mapping cases. The next map uses CartoDB dark matter for the tileset. Despite being dark-themed, I find it hard to read, so we will not be using it here. The last map uses OpenTopoMap for the tileset. This is a topographic map and gives more geographic details than the others. There are more tileset options, but I am going to stick to the OpenStreetMap set. Now that we have a map, we can start focusing on map markers. For now, all we need for a marker is a location and what icon to use. The location is a latitude-longitude pair used to define where the marker is at, just like the map's initial center location. The icon is generated with its own function, which we will use to define the icon image and color. The icon can either be from Font Awesome's free set or Bootstrap's glyph icon. Here we are creating some icons to get a feel for some of the built-in color options and some Font Awesome icons. The markers look pretty good, so the next step is to add numbers to them. Since we already have icons using Font Awesome, we will try using the numbers available there. These numbers are centered on the marker and look pretty good. I do need to support double-digit numbers, so we can check that case here. Unfortunately, this presents an issue as the marker renders, but the icon is missing. Checking Font Awesome's icon list, 0 through 9, are represented, but it does not have double-digit numbers, which makes sense because these are actual icons, not text. After going through a variety of other options, I found that this problem has already been solved for us. Let me present the Beautify Icon plugin for Folium. It exposes Leaflet's Beautify icon and comes from this Beautify Marker GitHub repo. The icon parameter uses the same Font Awesome icons that are in Folium's built-in icon class. The icon shape parameter is a new one. It defines what the marker shape looks like from a small set of options. I will just be using the marker option to keep the same look we had before. The border color parameter specifies the border color that goes around the icon shape using standard HTML color codes. The background color parameter specifies the background color for the icon shape the same way. The text color parameter specifies the color for anything provided in the number field, also in HTML color codes. Finally, the number parameter specifies the number to display instead of an icon. The number can actually be normal text as well. though only 2 or 3 characters will fit inside the icon shape. It is important to note that the icon and number fields are mutually exclusive, and supplying a number will use that instead of the supplied icon. Here we generate a few sample markers using Beautify Icon. We set the border and background colors to red and white and test a plain icon and some numbers. Now that we have all the pieces we need for our map, we can focus on getting the data from our CSV file instead of making up latitude and longitude locations. Here's what our sample data looks like. It is just a CSV file containing latitude and longitude columns. Other columns can be added as needed and would not interfere with our code. The latitude and longitude values can repeat, so they are not unique in the file. In the code, we just open the file and examine each row with the help of the Build in CSV module. The CSV Dictionary Reader function will parse the CSV data and grab the column names from the header line if they are present. This makes it easy to loop through each row and examine the columns. Since we only want the latitude and longitude pairs and how often they repeat, we can make a dictionary using the latitude and longitude together as the key and use a counter as the matching value. For simplicity, we just check if the latitude and longitude are already in the dictionary or not, and update the count. Here is a print out of what we have gathered from the CSV. See each latitude and longitude pair and how many times they occur in the CSV file. The last piece we need to figure out is how to save the map. Fortunately, Folium has a save function that allows saving as an HTML file. Since we save into an output folder, we do a check to be sure the folder exists and create it if it does not. Now that we have all the pieces needed to make our map, we can put them together. First, we will make the map so we have something to tack the markers on. Then we simply gather the latitude and longitude along with their number of occurrences as before. We loop through them and create map markers for each one. Finally, we save the map to an HTML file. With all the pieces together, we can do some small refactoring to split some of the ideas into their own functions. The refactor is mostly splitting tasks up into smaller functions. Being a small script, there is not a lot of value in it. But if this were to grow, these functions would become a reusable part of a larger whole. This final code is available separately from the larger notebook in the map.py file. And that's everything. Thank you for watching Dark Mode Code. Let me know what you think. Did I go into too much or too little detail? Did you decide to try the code yourself? Is there some